Okay, I hope most of you are there. Let us start for inorganic part. This is you can see screen, right? This is USCH 302, मतलब paper 2 का unit 2, which is inorganic chemistry part. In that you have selected topics in P block elements, and there are then 3 subtopics in that unit. So let us see. In this topic, you have 3 subparts that I told. One, very first is chemistry of boron compounds. Second is chemistry of silicon and germanium and their compounds. And third is chemistry of nitrogen family elements. And all three are very important and basic chemistry parts out of other topics. So these three are very important, even though if you don't opt for TY chemistry, then also don't neglect these three topics, okay, because these are very useful compounds of chemistry that you will require everywhere. So prepare for this topic carefully. Since 3 sub-units are there, today we will deal with very first unit, chemistry of boron compounds. Tomorrow we will deal with rest of 2. अगर पहला यूनिट बहुत अच्छे से समझ में आया तो silicon family, that is carbon family elements and nitrogen family elements, we can wind up in very short time. Okay, so we'll move ahead with chemistry of boron compounds, which is subunit of major unit 2. Okay, you can see this periodic table. In periodic table, elements are arranged with respect to their increasing atomic number, right? So from hydrogen up to last element, all elements are arranged in their increasing atomic numbers, and in which orbital outermost electron enters. Okay, in which orbital outermost electron enters, that element is placed in that orbit, that block. Like if there is in general skeletal of periodic table, you can see there are 4 blocks: S block, P block, D block and F block. Okay, so on my left hand side, it is left hand side of periodic table. Oh, so okay, so this is left side of periodic table, left hand side. Okay, though you can see पीरियोडिक टेबल की जगह पे आप जाके बैठे तो वो राइट हैंड दिखेगा, बट जब भी लेफ्ट हैंड राइट हैंड का आता है तो your left hand is periodic table's left hand. So when periodic trends are explained, it is from left hand to right hand. Okay, from left hand side to, from left to right, how periodic properties move. So it is left hand side is nothing but your left hand side, and this opposite side will be right hand side. So S block element मतलब क्या? Outermost electron enters in S orbital, and P block element is what? Outermost electron enters in P orbital, which is outermost. Okay, so S block contains first A element, second A element. It was previous nomenclature. Now it is group 1, group 2 elements. Group 1 are called as alkali metals. Group 2 are called as alkaline earth metals. Whereas in P block, the columns are 13, 14, 15, 16, 17 and 18, where column 18 elements are very special elements. They are also called as noble gases. Okay, inert gases. They don't show reactions at normal temperature conditions. They are highly stable because their octet is completed. Okay, rest of elements are 13 to 17. So this all this group of element form p block elements, and p block is combination of metals, non-metals, semi-metals. Okay, so p block is very interesting part of uh, elements in periodic table. Now let us see the what are main group elements. So, main group elements are nothing but combination of S block and P block elements. Okay, combination of S block and P block elements. And if you see basic periodic property of atomic size, ionic size, then as we move down the group, okay, ये अगर group number 1 है मेरा, as I move down the group, then atomic size or ionic size increases. This increase is because of addition of different shells. Okay, shell मतलब क्या, ये outermost cover. Okay, तो centrally placed अगर मेरा न्यूक्लियस है, तो न्यूक्लियस के ऊपर कितने कवर्स है? इनडायरेक्टली दैट विल गिव मी साइज ऑफ एटम. बहुत सारे कवर है, एटम बहुत फैट है, बहुत कम कवर है, एटम थिन है. ओके, और उसमें हाइड्रोजन एक ही लेयर रहेगा. दिस रो नंबर 1 2 3 4 up to 7 indicates number of coatings, number of cover, number of shells surrounding your central nucleus. So as we move down the group, you can see number of coatings are increasing. So एक layer पहला, दूसरा layer, तीसरा layer, this way your size of ball increases. Ball in the sense here we are calling atom as ball. So अगर वैसा रहा arrangement, तो your atom, this last element will be biggest element and this will be smallest element, hydrogen. Okay, so um, as we move down the group, atomic size increases. As we move from left hand side to right hand side, atomic size decreases. Okay, atomic size decreases here. This is because of you can see from lithium to neon. Okay, from lithium का atomic number है 3, neon का atomic number है 10. You can see all electrons are added, electrons are present, and there are only two covers, two shells or two orbits. Okay, ये पूरा circle मतलब एक orbit, and in given orbit you have different orbitals. So in second shell or second orbit you have 2s and 2p orbital. 2s orbital मतलब क्या? s orbital having capacity of 2 electrons. एक ही orbital है 2s orbital having a capacity of 2 electrons, whereas 2p orbital, every p orbital is there are 3 suborbitals px, py, pz, and since each suborbital has capacity of occupying 2 electrons, total 6 number of electrons can be accommodated in p orbital. Okay, so for s orbital, for s orbital, s orbital capacity is 2 electrons and p orbital's capacity of occupying electrons is 6. Okay, so effective nuclear charge increases left to right due to, okay, Pratibha, you are right. So from as we move from left to right, I think this concept you have very much cleared in your FYBSc. So from left to right, since electrons are added in shell, same shell, effective nuclear charge. Okay, effective nuclear charge मतलब क्या? With this image you can see initially number of electrons are less, one shell. Then when second shell is added, the innermost electrons repel your outer electrons. Okay, so whatever charge, whatever force of attraction is experienced by outermost electron is less as compared to inner shell electron. This is shielding effect. shielding effect. This electron layer, the middle electron layer, shields your nucleus from attraction to outermost electrons. So outermost electrons are not that much strongly bonded with nucleus as compared to inner electrons. Okay, so as we move from left to right due to addition of electrons in same shell, effective nuclear charge increases, thus atomic size decreases. So if you see different trends in this, we are interested in now boron family elements. Okay, this group of elements. And for this group of element there is boron, 13 group elements. Boron, below boron there is aluminium, gallium, indium and thallium. So remember these names: boron, aluminium, gallium, indium, thallium. Okay, so बोरॉन इज दिस फैमिली इज कॉल्ड एज बोरॉन फैमिली. जो भी फैमिली का फर्स्ट मेंबर रहता है ना, उसको वो फैमिली मेंबर बोलते हैं बोरॉन फैमिली. नेक्स्ट विल बी कार्बन फैमिली, नाइट्रोजन फैमिली, ऑक्सीजन फैमिली एंड सो ऑन. सो दिस ग्रुप 13 is called as boron family elements, where it contains boron atomic number 5, aluminium atomic number 13, उसमें 8 ऐड करने से, then gallium 118, indium, then there is thallium. So this is boron group of elements. Now, as far as the atomic size and ionic size is concerned, along this group, what will happen? Atomic size, ionic size, it will increase, of course. Boron is will be smaller in size, thallium will be larger in size, but whatever the periodic increment is there, it is not found in this case because of insertion of um, d orbital for gallium and insertion of f orbital here after indium. So because these two orbitals insert and because of their cloud expanding effect, the size is not increasing that much properly periodically. Okay, मतलब जो interval होना चाहिए increment का, that is not there for this group of elements, but definitely it increases as we move down. As far as electronic configuration is concerned, okay, here electronic configuration of every column is given. When you are now interested in second, for this row number gives you outermost orbital, and so that is your outermost s orbital. For every electronic configuration, for every electron, that shell starts with s orbital, ends with p orbital. Okay, so when s starts with exception is only first shell, there is no p orbital. For second shell starts with 2s orbital and ends with 2p orbital. Third shell starts with 3s orbital and ends with 3p orbital. Okay, then fourth shell starts with s orbital and it ends with p orbital. But here there is since d orbitals occupy n minus 1 level, the 3d orbital uh, because of its cloud expanding effect, instead of occupying this third shell, this goes to fourth shell. So in case of fourth shell starts with a s orbital, ends with p orbital, but in between there is d orbital. Same way, you have 5s shell starts with 5s and ends with 5p, but in between there is 4d orbital. Okay, now in case of sixth shell also starts with s orbital, ends with 6p orbital, but in between there is 5d orbital and 4f orbital. Okay, so uh, every shell you can see first shell, then second shell starts with, ends with, then third shell starts with s orbital, ends with p orbital, fourth shell starts with s orbital, ends with p orbital, fifth shell starts with s orbital, ends with p orbital, sixth shell starts with s orbital, ends with p orbital. In between there are n minus 1 d orbitals and n minus 2 f orbitals. Okay, so this is electronic configuration. In case of gallium, this d orbital comes, because of that size drastically changes. In case of thallium, f orbital comes, therefore size again drastically changes. So from boron to thallium, atomic and ionic size increases, but that increase is not regular increase. Okay, that increase is not regular increase. So therefore one cannot give proper increment or decrement in atomic size. It changes irregularly. Now, as far as the metallic character is concerned, okay, to whom we are calling metal, which can lose electron, which is having electron that can move freely, are metals. Okay, so metallic character, if we see in main group elements, then as we move down the group, atomic number increases, atomic size also increases, screening effect of inner electrons increases, and hence effective nuclear charge decreases down the group. As atomic size increases, effective nuclear charge decreases. As a result, atom loses electrons easily. Okay, atoms loses electron easily. So as we move down the group from boron to thallium, metallic character increases. Okay, as we move down the group, metallic character increases, and in case of these group elements, boron family elements, boron is non-metal. Okay, boron is non-metal, whereas aluminum, gallium, indium, thallium, all are metals. Okay, all are metals. Only boron is non-metal. This non-metallic character is because of small size of boron. Okay, because of small size of boron, the outermost electron, which is present in 2p, is attracted strongly by nucleus. Therefore that electron is not easily lost, and hence boron is नॉन मेटल. अगर मेटल रहता है तो वो that outermost electron should be free to move, but in this case it is not free to move. So therefore boron is non-metal, whereas aluminum, gallium, indium and thallium shows metallic character. Then oxidation states of these oxidation states of elements in main group uh, elements. Oxidation state of element is what? It is residual charge left on central atom when other atoms of compound are removed, okay, in their usual oxidation state. Like अगर मेरे पास बोरॉन ट्राइक्लोराइड रहता, BCl3 रहता, तो if I remove this chlorine, तो 1 chlorine carries 1 - charge, 3 chlorines are there, 3 क्लोरीन ने अपना माइनस चार्ज गवा दिया, तो बोरॉन के ऊपर रहेगा बोरॉन 3+, सो 3+ इज ऑक्सीडेशन स्टेट ऑफ बोरॉन. इन दिस वे यू कैन कैलकुलेट फॉर एनी एल्यूमिनियम ट्राइक्लोराइड रहता है ना, तो सेम वे एल्यूमिनियम एल्यूमिनियम ट्राइक्लोराइड AlCl3, तो 3 क्लोरीन्स मेरे रिमूव हो गए, तो एल्यूमिनियम पे बचेगा +3. सो if you see oxidation state, common oxidation state of element is it depends upon number of electrons in its valence shell. वैलेंस शेल में कितने इलेक्ट्रॉन्स है और उसको ऑक्टेट पाने के लिए कितने इलेक्ट्रॉन्स लगेंगे, that decides that decides whether oxidation state is high or low, or will show variable oxidation state. Here in case of first A group elements, since electronic configuration is ns1, ये एक इलेक्ट्रॉन लूज करके वो स्टेबल हो जाएंगे. In case of alkaline earths, electronic configuration is ns2, just by losing 2 electrons they will get stable state. So therefore these elements lose electrons or their electrons are free to move. जाना है तो जा सकते हो, रहना है तो रह सकते हो, ऐसा है metals का, alkali and alkaline earths. So therefore they are metals. In case of boron family now, in case of boron family, since the d orbital and f orbital comes in between, their sizes are different. There is effect of inert pair. Inert pair effect मतलब क्या? If you take electronic configuration of boron, it is what boron lies in second row. Okay, boron lies in second row. So therefore n value क्या आएगा? 2, 2s2, 2p1. This is the okay, this ns2np1 is general electronic configuration for boron group. ns2 np1 is general electronic configuration for boron group. तो बोरॉन का लिखने के लिए जस्ट रिप्लेस n वैल्यू इक्वल टू 2, क्या हो जाएगा? 2s2 2p1. एल्यूमिनियम का लिखना है मुझे. फॉर एल्यूमिनियम ऑल्सो इलेक्ट्रॉनिक कॉन्फ़िगरेशन विल कम लाइक दिस, बट क्या आएगा? रो नंबर 3 आएगा, n वैल्यू 3 आएगा, 3s2 3p1. फॉर गैलियम it is 4s2 or 4p1, but in between 4s and 4p there is 3d. तो गैलियम का इलेक्ट्रॉनिक कॉन्फ़िगरेशन क्या आएगा? 4s2 3d10 and 4p1. ओके, इंडियम के लिए क्या आएगा? 5s2 4d10 and 5p1. ओके, गैलियम और इंडियम के लिए d ऑर्बिटल आएगा इन बिटवीन, बट वो d ऑर्बिटल क्या आएगा? अगर फोर्थ शेल रहा तो 3d आएगा, फिफ्थ शेल तो 4d आएगा. नाउ इन केस ऑफ थैलियम, थैलियम के लिए क्या आएगा? 6s2 5d10 4f14 and 6p1. उसमें p और d ऑर्बिटल्स ऑक्यूपाई हो जाएंगे. ओके, दिस इज जनरल इलेक्ट्रॉनिक कॉन्फ़िगरेशन, और उससे आप लोग डिराइव कर सकते हो. सिर्फ सीक्वेंस में याद रखने के लिए जस्ट रिमेम्बर ये वाला. ओके, दिस आई विल कॉपी from here and will keep. फिलिंग। ओके, सो इलेक्ट्रॉन्स फिल होते टाइम जब 4s आएगा ये गैलियम के लिए तो उसमें 3d ऑलरेडी फुलफिल्ड रहेगा, एंड जब 5s आएगा तो 4d ऑलरेडी फुलफिल्ड रहेगा। थैलियम के टाइम पे 6s ऑलरेडी फुलफिल्ड रहेगा, 6x के टाइम पे 5d और 4f फुलफिल्ड रहेंगे। ओके, देन in oxidation state, what is happening for boron? Your oxidation state is electronic configuration is 2s2 2p1. Okay, for aluminium also oxidation state is 3s2 3p1. But now for case of gallium, indium and thallium, their electronic configuration is 4s2 3d10 and 4p1 for gallium. So same is reflected in others, only shell number is added. But what is happening? The outermost electron pair in s orbital, for gallium it is 4s orbital, that electron pair doesn't take part in bonding, or it is or that electron pair has become inert, so that it is not taking part in bonding, and is called as inert pair effect, where reluctance of ns इलेक्ट्रॉन पेयर, जो एस ऑर्बिटल में का इलेक्ट्रॉन पेयर था ना, 4s2 4p1 जो इलेक्ट्रॉनिक कॉन्फ़िगरेशन हुआ, so that 4s2, that two electron pair, that electron pair is not taking part in bonding, and therefore it is called as inert pair effect. Now because of that क्या होगा, जब बाकी के कंपाउंड लाइक बोरॉन फॉर्म होगा, तब बोरॉन के टाइम पे इलेक्ट्रॉनिक कॉन्फ़िगरेशन क्या है बोरॉन में? In case of boron, electronic configuration is 2s2 2p1. ओके, तो ये दिस इधर ये 2 आएगा, 2s2 2p1. So in case of boron, what is happening when there comes 3 chlorine atoms from surrounding in the vicinity of boron, all these 3 are removed. All these 3 electrons, 1 electron from p orbital, 2 electrons from s orbital are removed. Uh, Sorry, let me show it in block diagram. Okay, this is your this is what this is your 2s orbital, 2s. Okay, this is your 2px, आगे वाला जाके 2py, और आगे वाला रहेगा 2pz ऑर्बिटल। ओके, तो शुरू में क्या रहेगा, दिस ऑर्बिटल विल कंटेन पेयर ऑफ इलेक्ट्रॉन। ओके, तो इधर 1 इलेक्ट्रॉन, ये पेयर ऑफ इलेक्ट्रॉन इसमें रहेगा, और योर px विल कंटेन ओनली 1 इलेक्ट्रॉन। सो कि ये अपवर्ड एरो वाला रहेगा, इतना याद में रखो। ईयर वन, दिस इज नॉट वन, इलेक्ट्रॉन पेयर दिखाने के लिए मैंने लिखा है ऐसा। ओके, सो ये रहेगा आपका कॉम्बिनेशन एट ग्राउंड स्टेट। ओके, दिस इज एट ground state of atom, ground state of boron. Now in excited state, what will happen when two electrons, when three chlorine atoms comes in vicinity in excited state, okay, of these two electron, this out of these two electron, one electron will excite from 2s and will go in 2p. Okay, and will go in 2p orbital, and there and hence three unpaired electrons are uh, there. So when there will be bonding, it will go in +3 oxidation state. This is how it shows +3 oxidation state. But now in case of gallium, indium and tellurium, this s electron pair, okay, this s electron pair is not taking part in bonding. Therefore only one electron bonds. So this electron pair becomes inert. This electron pair becomes inert in case of gallium, indium and tellurium, and hence for boron and aluminum common oxidation state is +3, all three electrons involved, whereas for gallium, indium and thallium this only px electron takes part in bonding. This 2s electron pair remains as it is non-bonded. Okay, so this is electron pair effect. Now next trend is melting point and boiling point. As far as melting point and boiling point is concerned, it is the trend is not regular as like atomic size. This is because your different nature of elements present in this group. Boron is non-metal, right? Boron is non-metal, whereas aluminum, gallium, indium and tellurium are metals. So out of these, indium, aluminum and thallium forms close packed structures. Okay, close packed structure, whereas gallium only forms diatomic molecules like structure. Okay, structure like diatomic molecules. So melting point, as we move from indium, aluminum to indium, melting point decreases. Okay, melting point decreases and then again it starts to increase. This increase and decrease is because of different crystal structures. So your aluminum is having different crystal structure, indium is having different crystal structure, thallium is also having different crystal structure. Here interestingly, this gallium, okay, gallium, which is having structure like a diatomic molecule, it has melting point remarkably slow as and it is very interesting to look like आपने जब बॉटल लेते हो गैलियम मेटल का, तो बॉटल में metal is in solid state. Okay, metal is in solid state. As soon as you take that metal and keep on your palm, अगर हाथ पे रखा, तो that gallium melts. ओके, दैट गैलियम मेल्ट्स, और वो जादू दिखाने के लिए ऐसे सॉलिड रखते ही, सॉलिड हाथ पे रखते ही लिक्विड हो जाता है. तो दिस इज बिकॉज लो मेल्टिंग पॉइंट ऑफ गैलियम. मेल्टिंग पॉइंट ऑफ गैलियम इज जस्ट 37 डिग्री सेल्सियस. ओके, मेल्टिंग पॉइंट ऑफ गैलियम is let me confirm. Melting point is 38 38 39 डिग्री सेल्सियस। ओके, सो और बॉडी टेम्परेचर कितना रहता है? 36 प्लस। तो वो टेम्परेचर पे गैलियम स्टार्ट्स टू मेल्ट। तो जैसे ही बोतल में से निकाल के हाथ पे रखा तो गैलियम मेल्ट हो जाता है। इट इज very common question whenever there is general science quiz or chemistry related quiz. Gallium melts when it is kept on palm. Okay, so this is about melting point. Now the next concept is, okay, up to now जो introduction part हुआ उसमें क्या क्या याद रखना है, I will tell you. Chemistry of boron elements में elements in group कौन कौन से है? बोरॉन फैमिली में है बोरॉन, एल्यूमिनियम, गैलियम, इंडियम, टेलुरियम। ओके, बोरॉन का सिंबल है बो, बी सॉरी, बोरॉन का सिंबल इज बी, एल्यूमिनियम का सिंबल ए एल, गैलियम का सिंबल है जी ए, इंडियम का सिंबल इज आई एन, एंड थैलियम का सिंबल इज टी एल। ओके, तो कंफ्यूजन कभी कभी क्या होता है, इफ क्वेश्चन कम्स लाइक विच ऑफ फॉलोइंग इज नॉट एलिमेंट ऑफ बोरॉन ग्रुप और ग्रुप 13, और अगर उसमें गैलियम की जगह जी ए पे के जगह पे जी ई डाला। ओके, जी ई इज व्हाट? जर्मेनियम, और जी ए गैलियम है। तो सिंबल्स याद में रखते टाइम प्रॉपरली रखो। IN is indium and SN is tin, तो उसमें भी कंफ्यूजन नहीं होना चाहिए। तो रिमेंबर एलिमेंट्स प्रॉपरली, तो कंफ्यूजन नहीं होगा। बोरॉन फैमिली एलिमेंट्स आर बोरॉन, एल्यूमिनियम, गैलियम। ओके, गैलियम हाथ रखते ही पानी हो जाता है उसका, गैलियम, एंड देन इंडियम, थैलियम। बोरॉन फैमिली एलिमेंट्स है। देयर जनरल इलेक्ट्रॉनिक कॉन्फ़िगरेशन इज NS2 NP1, और ये वेरी करने के लिए जस्ट गो ऑन एडिंग इलेक्ट्रॉन्स। तो आपको जो शेल चाहिए वो शेल इधर मिल जाएगा। अगर थर्ड रो को है तो उसका इलेक्ट्रॉनिक कॉन्फ़िगरेशन उधर मिलेगा। ये इसमें वैल्यूज डालते ही आपको मिल जाएगा। वेर N इज आउटर मोस्ट शेल नंबर। इलेक्ट्रॉनिक कॉन्फ़िगरेशन याद में रखा, नेम ऑफ एलिमेंट्स याद में रखे। मेटालिक कैरेक्टर, एज वी मूव डाउन द ग्रुप, since ionization energy decreases, metallic character increases. Thallium is good metal, boron is non-metal, aluminum, gallium, indium, thallium all are metals. Okay, then oxidation states. Oxidation state, common oxidation state is +3, कॉमन ऑक्सीडेशन स्टेट इज +3। तो +3 के लिए ये S में के 2 इलेक्ट्रॉन और P में का 1 इलेक्ट्रॉन लूज करेगा, तो कॉमन ऑक्सीडेशन स्टेट +3 हो जाएगा। बट इन दिस केस ड्यू टू इनर्ट पेयर इफेक्ट, ड्यू टू inert pair effect, gallium, indium and thallium do not show +3 oxidation state, they show +1 oxidation state. This NS2 electron pair remains as it is. Then uh, this is about electron pair effect. Then melting point and boiling point, um, their trend is not regular in group, but the elements from aluminum to indium melting point decreases, and for thallium melting point again increases. This is because of different crystal structures, and remember the code for gallium. Okay, then the second half of topic is electron deficient compounds of boron family element. Okay, and their Lewis acid character. Lewis acid किसको बोलते हैं? Lewis acid Answer please. Levy's acid. Levy's acid. Only 65 are there. Which accept electron or electron pair. Electron pair. Okay. Accepts electron pair means what? Its outermost orbital, in its outermost shell there should be vacant orbitals. अगर vacant orbital नहीं रहेंगे तो that element should not accept electron pair. Okay, so these boron family elements, since they have electron pair in them, they have vacant orbitals in them, they can accept electron pair, so they are Levy's acids, and they're called as electron deficient compounds. Electron deficient compounds का definition क्या है? Compounds in which compounds in which number of valence electrons that are available. Okay, तो बोरॉन के पास कितने वैलेंस इलेक्ट्रॉन्स अवेलेबल है? ओनली 3 इलेक्ट्रॉन्स. 2s ऑर्बिटल के 2 इलेक्ट्रॉन्स एंड 2p ऑर्बिटल का 1 इलेक्ट्रॉन. Okay, the compounds in which number of valence electrons that are available are less than minimum electrons required to form covalent bond. Okay, तो जितने outermost इलेक्ट्रॉन होने चाहिए थे उतने इलेक्ट्रॉन होते नहीं है, तो that number is less, therefore they are called as electron deficient. अगर दो बॉन्ड बनाने हैं तो टोटल 4 इलेक्ट्रॉन्स लगेंगे. फॉर वन बॉन्ड यू रिक्वायर 2 इलेक्ट्रॉन्स, वन फ्रॉम वन एटम अनदर फ्रॉम अनदर एटम. सो दिस वे अगर दो बॉन्ड बनाने तो यू रिक्वायर 4 इलेक्ट्रॉन्स. अगर 4 इलेक्ट्रॉन्स अवेलेबल नहीं है तो दैट कंपाउंड यू आर कॉलिंग इट एज electron deficient compound. In other words, molecule which contains atoms that have more stable low energy atomic orbitals, okay, that have more stable low energy atomic orbitals than total number of electrons in valence shell, then total number of electrons in valence shell are called as electron deficient compound. Okay, for example, डाइबोरेन का फॉर्मूला है B2H6. डाइबोरेन इज B2H6. तो दो बोरॉन हाइड्रोजन के साथ कितने बॉन्ड बना रहे? 6 बॉन्ड. तो वन बोरॉन कितना बनाएगा? 3 bonds. Okay, so for making 3 bonds you require how many electrons per boron? 3 twos are 6. So 6 electron from each boron are required, but there are not 6 electron in boron. Okay, so therefore this type of compound is electron deficient compounds. And if we see Levy's character of boron family halides. Okay, बोरॉन फैमिली हेलाइड्स मतलब क्या? बोरॉन हेलाइड्स, बोरॉन के हेलाइड्स, बोरॉन BF3, बोरॉन ट्राइक्लोराइड, बोरॉन ट्राइब्रोमाइड, बोरॉन ट्राई आयोडाइड. तो if you see Levy's acid character, BF3 is weak acid than Bi3. The reason you are knowing. The reason is since iodine is large in size. Okay, since iodine is large in size, the bond between boron and iodine is not very strong. Okay, whereas bond between boron and fluorine is very strong. Dissociation is this dissociation is not possible. Then boron iodide. hence BF3 is strong Lewis acid. It can accept electron pair strongly. Remember this trend, BF3 is weak acid and Bi3 is strong acid. Then in hydrides of boron, you have classification and then sum of elements. Okay, so boron makes bond with hydrogen. Boron makes bond with hydrogen and forms compounds. So here there are three types of boron hydrides are there. They are also called as boranes. Okay, boron hydrides of boron are also called as boranes, and there are three types. Very first type is closoborane. Its general formula is CnHn2 minus. Okay, this 2 minus is charge. BnHn2 minus. Its example is B6H6 2 minus, where 6 borons lie in on the corner of octahedron. Okay, just imagine one octahedron, or and each corner of octahedron is occupied by boron. Then second class is nidoboranes. In nidoboranes, in nidoboranes, uh, the general formula is BnHn plus 4. Okay, Hn plus 4. Example is B5H9. तो इसमें क्या होता है, 5 borons lie on corner of square pyramid where one corner is removed. Okay, थोड़ा ये complete नहीं हुआ ना. Then in arachno it is BnHn plus 6. Okay, nido में क्या है 4, arachno में 6. Its example is B4H10. 4 borons lie on corner of octahedron. 2 corners are removed. Okay, so when it is BnHn 2 minus, all 6 atoms occupy corner places with no corner removed. BnHn plus 4, तो स्क्वायर पिरामिड रहेगा तो one corner is removed. And arachno BnHn plus 6, अगर एग्जाम्पल B4 का रहेगा तो ऑक्टाहेड्रॉन के 2 corners are removed. Okay, so this is classification. Just in classification, remember closo के लिए BnHn 2 minus. At least remember nido and arachno. Nido में क्या है BnHn plus 4, arachno में है BnHn plus 6. Okay, this study of hydrides of boron was done by scientist Lipscomb, and he got Nobel Prize for discovery of, what you can say, invention of all those compounds of hydrides of boron. Now you have for your syllabus 2 compounds. One is diborane. Okay, one is diborane, another one is tetraborane. So diborane, its formula is B2H6. B2H6, where N is 2, तो फॉर्मूला में क्या हो जाएगा, N2 रखने के बाद B2H2 plus 4 will be 6. This is under nidoborane. Diborane is nidoborane type of category. तो अरेचनोबोरेन रहता तो कितना आ जाता N plus 6, तो इधर 8 हो जाता B2H8. तो वो वाला बोरेन आपका arachnoborane रहता. This diborane B2H6 is nidoborane. The structure of diborane is like this. Two BH3 groups are there, but if you see bonding, then on one boron atom there are two terminal hydrogen atoms. Okay, you can see this. These are terminal hydrogen atoms. Atoms which are free bonds with hydrogen, they are called as terminal hydrogen atom. In case of diborane, how many terminal hydrogen atoms are there then? कितने देखो? In case of diborane, this is 1, 2, 3, 4. 4 terminal hydrogen atoms are there in diborane. Then two hydrogen atoms are linked. Okay, two hydrogen atoms are linked to boron atoms via bridge. Okay, via bridge, and they are called as bridged hydrogen atom. And they are bridged in such a way that the bridge boron hydrogen boron is not three centered two electron. Okay, इसमें एक बोरॉन ने कितने हाइड्रोजन के साथ बॉन्ड किया है? दिस इज 1, दिस इज 2. बट ये अगर देखा मैंने बोरॉन हाइड्रोजन बोरॉन, तो these three centers are there, but only two electrons are involved. Okay, only two electrons are involved in this. And therefore this bond is called as three centered two electron bond. अपना usual जो covalent bond रहता है, your usual covalent bond is टू सेंटर टू इलेक्ट्रॉन बॉन्ड. ओके, ये टर्मिनल के साथ जो बॉन्ड हो गया है, ये टू सेंटर टू इलेक्ट्रॉन बॉन्ड है. वेयर इज दिस बॉन्ड बिटवीन boron hydrogen and boron, this bridge bond is three center two electron bond. So you have such a type of two bonds are there, and the upper one ek, lower one ek. Since this bond looks like a banana, okay, therefore this three center two electron bond is also called as banana bond. Okay, this bond is also called as banana bond. So as far as the boron is concerned, boron in this case undergoes sp3 hybridization. Remember this. In case of diborane, boron undergoes sp3 hybridization, and total 12 electrons are involved. How 12 electrons? This boron with terminal bond. तो terminal कितने electron से बनता है? 2 electron 2 center. Okay, so 2 electrons for this one, 2 electrons for this one. 4 इलेक्ट्रॉन हो गए ये साइड में सेम वे, और 4 इलेक्ट्रॉन ये साइड में. 4 + 4 8 electrons for bond between terminal hydrogen and boron. Okay, since four terminal hydrogens are there, each terminal hydrogen makes bond with central boron with two center two electrons. So total 4 into 2 8 electrons will be involved there, plus the for bonding between boron hydrogen boron bridge bond, there are two bridges. Each bridge consists of three center two electron. So each bridge is made up of bonding between two electrons, and therefore total 4 electrons will be involved in this bridge. So therefore total 8 for terminal and 4 for bridging hydrogens will be required. Total 12 electrons are involved in bonding. So this is structure of boron, where you can see the length of bridge bond. Okay, length of boron hydrogen bridge bond is more, 131 picometer, and the length of boron hydrogen terminal is short, so this length is more. Also, the bond angle between hydrogen, boron and hydrogen is 97 degrees. It is not usual sp3. And the bond between terminal hydrogen, boron and hydrogen terminal is 120 degree. Okay. Uh, and bond between bridged boron hydrogen boron is 83 degrees. So this structure, though boron has undergone sp3 hybridization, but bond angle and bond lengths are different. So this type of structure is different because of electron deficient nature of uh, this type of compound. The second compound involved in this is tetraborane. Its formula is B4H10. Okay, in this formula is B4H10. It is arachno type of borane. Arachno type of borane. तो आपका डाइबोरेन था निडो. Diborane is nidoborane, and tetraborane is arachnoborane. तो उसमें BnHn+6. तो B4 टेट्राबोरेन में B4 रहेंगे. B4H10 is molecular formula of tetraborane. Now in this case, if you see structure of tetraborane, for structure of tetraborane, bonding is little different from your diborane. Diborane जब form हुआ था, there was no boron boron bond. Okay, boron boron bond नहीं था. No boron boron bond. हम्म तो इसमें बोरॉन बोरॉन बॉन्ड नहीं था. But in case of tetraborane, there is one bond between boron and boron. Okay, and these borons are not adjacent borons. These borons are not adjacent borons. So you can see here this, if we number boron atoms, if this is boron number 1, 2, 3, 4, then boron number 1 makes bond with boron atom number 3. And so there is one in bonding, there is boron boron bond 1. So number of electrons involved are 2 electrons. Okay, 2 electrons. Then in this case, if you see terminal bonds, boron bonded with hydrogen, then this is 1, this is 2, 3, 4, 5 and 6. In this case, 6 terminal boron hydrogen bonds are present. Okay, so boron hydrogen terminal bonds are 6, and therefore for one bond it requires 2 electrons, so total 12 electrons are used here. Then in this case, number of boron hydrogen boron bridges. Okay, so this is one bridge, this another bridge. So total four bridges are there. So you can write boron hydrogen boron bridges ne four. So therefore each bridge contains two electrons. Okay, though it is three centered, but contains two electrons. So therefore, eight electrons will be involved in this case. So if you count total number of bridges, total number of electrons, and total number of this, you will get total. How many electrons will come out? 22. 22 electrons will be there, okay, in uh, this structure. Actual requirement कितना रहता? इसका डबल हो जाता ना, ये वन 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 इलेक्ट्रॉन प्लस फोर इलेक्ट्रॉन्स एडिशनल लगते, बट सिंस फोर इलेक्ट्रॉन्स आर लोअर, this is your electron deficient structure. And here also boron undergoes sp3 hybridization. Okay, आपका डाइबोरेन में भी बोरॉन का hybridization था sp3. Here also you have hybridization sp3. Actually for your regular offline mode, you have everything in detail, but now since this is your online mode of teaching, and we are too late to start this topic, so therefore we are not taking in details of this. So this is about tetraborane, and next element, next compound of boron is borax. किधर यूज किया था बोरेक्स, फटाफट बताओ. बोरेक्स, it is primary standard, right? Borax is primary standard used to standardize what? Okay, Kushal, you are asking one question: how hydrogen is able to form two bonds if its valency is 1? See, this is in the case of, we will just will go back. In the case of boron, hydrogen, and boron, this is bridge bond. Okay, three centers are involved. Three centers are involved here, and when there is formation of this, what you are calling it as banana bond, then the overlap is 1s orbital of hydrogen overlaps with boron atom. Okay, overlap with uh, sp3 hybrid orbital of boron. So one electron from hydrogen is there, and either one electron from this boron or one electron from this boron. So that electron is delocalized here. So overall वन इलेक्ट्रॉन फ्रॉम ईच हाइड्रोजन, ऊपर वाला ब्रिज और ये नीचे वाला ब्रिज अगर कंसिडर किया, तो ये ब्रिज में का हाइड्रोजन का एक इलेक्ट्रॉन, हाइड्रोजन का एक इलेक्ट्रॉन, बोरॉन का एक इलेक्ट्रॉन, बोरॉन का. सो दिस delocalization of electron takes place. Okay, delocalization of electron takes place, and hence this three center to electron, it is not regular टू सेंटर टू इलेक्ट्रॉन, टू सेंटर टू इलेक्ट्रॉन बॉन्ड मतलब क्या, योर रेगुलर बोरॉन हाइड्रोजन बॉन्ड. ओके, सो हियर दो इट लुक्स लाइक रेगुलर डॉट डॉट बॉन्ड दिखा रहा है ना ये आपको, बट इट इज नॉट लाइक दिस इज लाइक दिस. इधर दिख रहा है ये स्ट्रक्चर में. Okay, this is your banana bond. Three centers are involved and two electrons are there. So there are no three electrons और four electrons नहीं है. हाइड्रोजन के पास एक ही इलेक्ट्रॉन है और बोरॉन का ये शेयरिंग इलेक्ट्रॉन, so that three centers are involved and electrons are two. Three center two electron bond. Same way नीचे भी three centers two electron bond. Okay. I hope you have understood this. This is not two center two electron. अपना regular covalent bond रहता है वो two center two electron रहता है. This is three center two electron. Okay. Now, last one is borax. Borax you have used for what? किधर use किया था? Standardization of HCl क्या? इन स्टैंडर्डाइजेशन ऑफ HCl बोरेक्स यूज किया था. 0.38 ग्राम्स ऑफ बोरेक्स वे करके आए थे और वो डिसॉल्व किया था, वार्म वार्म करके डिसॉल्व किया था और उसको टाइट्रेट किया था. बोरेक्स इज योर प्राइमरी स्टैंडर्ड. इट्स फॉर्मूला इज Na2B4O7 10H2. Basically it is what? It is sodium salt of tetraboric acid. Okay, borax is sodium salt of tetraboric acid. And in your syllabus you have some synthesis part where it occurs, so for now just skip that part and remember its uses. Borax is used in as a cleaning reagent in many cleaning agents, many cleaning products. Borax is there. Okay, so in household laundry and in cleaning products borax is used. So just remember formula of borax. It is salt of tetraboric acid, sodium salt, and its uses. Okay, so in summary, what we have learned from boron family elements is their electronic configuration. Their general electronic configuration is Ns2 Np1. Okay, Ns2 Np1. So for any element you can make electronic configuration. Electronic configuration. इलेक्ट्रॉनिक कॉन्फ़िगरेशन कोई भी एलिमेंट का भी आप निकाल सकते हो. सो जस्ट पुट n वैल्यू रो नंबर 1 में एक भी एलिमेंट नहीं है तो कोई भी नहीं आएगा. रो नंबर 2 में यू हैव बोरॉन, तो 2s2 2p1. ओके, तो ये वाला बोरॉन के लिए बनेगा. ये थर्ड शेल में कौन है? एल्यूमिनियम. एल्यूमिनियम के लिए ये बनेगा 3s2 3p1. फोर्थ शेल में देखो कौन है? फोर्थ शेल यू हैव गैलियम 4s2 3d10. कैपेसिटी ऑफ d ऑर्बिटल इज 10 एंड 4p1. देन नेक्स्ट इज इंडियम. इंडियम आएगा फिफ्थ रो में, उसका इलेक्ट्रॉनिक कॉन्फ़िगरेशन ऐसे बनेगा. देन लास्ट आएगा थैलियम, उसका इलेक्ट्रॉनिक में Fb आएगा. ओके, so this is general electronic configuration of this group of elements. Then Okay, metallic character. Sorry, metallic character. As we move down the group, metallic character increases. Thallium is more metallic. Boron is non-metallic. From aluminum to thallium, metallic character increases. Uh, this slide you are not required to remember. Okay, so all comparisons are given here. You are not required to remember this. Oxidation state. So this you are not required to remember. Just remember oxidation state of boron family element. This one plus 3 plus 1 stable 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 for gallium to indium because of inert pair effect. And remember the definition of inert pair effect, that is reluctance of ns electron pair from taking part in bonding. मीन्स दैट ns इलेक्ट्रॉन पेयर, ये जो इलेक्ट्रॉन पेयर है किसका, गैलियम का, इंडियम का और थैलियम का, दैट इलेक्ट्रॉन पेयर इज नॉट टेकिंग पार्ट इन taking part in bonding, so therefore it is called as inert pair effect. Okay, और उसकी वजह से क्या होता है, सिर्फ यही इलेक्ट्रॉन, एक ही इलेक्ट्रॉन बॉन्डिंग में आ जाता है. तो इफ यू सी गैलियम इंडियम एंड थैलियम कंपाउंड्स, दे आर नॉट लाइक क्लोराइड लिया तो गैलियम सिंगल क्लोराइड GaCl is available, then GaCl3. Indium chloride InCl is also available, InCl3 is also available. Melting point, remember example of gallium. Electron deficient compounds का definition plus Levy's acid characteristics of halides of boron. Okay, then hydrides of boron में classification याद रखो. Classification में at least B and C आपके syllabus में है. B and C. निडो में N+4 आता है हाइड्रोजन, एरेचनो में N+6 आता है. ओके, देन निडोबोरिन का एग्जांपल, डाइबोरिन इन डिटेल है आपको स्ट्रक्चरल एनालिसिस, तो उसमें स्ट्रक्चर याद में रखो. इधर ये वाला स्ट्रक्चर याद में रखो, ये बनाना वाला स्ट्रक्चर याद रखा तो भी चलेगा. अभी तो कुछ ड्राइंग वगैरह नहीं करना है. रिमेंबर टोटल इलेक्ट्रॉन्स इन्वॉल्व आर 12. 12 इलेक्ट्रॉन्स कैसे आए वो भी याद में रहना चाहिए. 8 इलेक्ट्रॉन्स आर फ्रॉम BH bond. 4 BH bonds are there terminal, so each bond requires 2 electrons, so 4 into 2 8 आया ये. And this 4 is nothing but ये 3 centered 2 electron bond, okay, which is called as banana bond. Boron atom in diboron as well as in tetraboron is sp3 hybridized, and in case of diboron never show bond between boron and boron direct. Okay, there is no direct bonding between boron and boron. The bond is bridged bond. Okay, two boron atoms in diboron are connected via hydrogen bridge. Okay, via hydrogen bridges there are two bridges. Then tetraboron में भी स्ट्रक्चर्स याद में रखो. बोरॉन बोरॉन बॉन्ड्स 1 एक ही है. बोरॉन हाइड्रोजन बॉन्ड 6. Boron hydrogen boron bridges are 4. Total electrons involved are 22. Again this is electron deficient compound. Boron undergoes sp3 hybridization. Yes. Then borax formula and uses. Now preparation reactions are there but we are not going to cover those. So is there any doubt in this unit?